Okay, and we are back with example 2. So a designer of expensive leather jackets is creating 2 for the new season, a long one and a short one. Each short leather jacket requires 1 labor hour from cutting and 3 from sewing. And each long leather jacket requires 2 hours from the cutting and 4 hours from the sewing. This designer is sharing cutting and sewing services with other designers, and so there are only 32 labor hours per week available and 84 cut labor hours per week from sewing, and the distributor cannot take any more than 12 long leather jackets per week. If the designer makes $50 profit on each short and $80 on each long, how many jackets of each type should the manufacturer make in order to maximize the profit? So, jackets of each type, that's our unknown. So X will be the number of, let's just pick one. Which did they say first? The number of long coats. And Y be the number of short coats. This time we are again maximizing profit. So profit equals $50 for every short jacket and $80 for every long one, which was our X. So I guess I probably should have switched those around, but please forgive me. So we need to write our constraints. The cutting department limits what we're able to do. So we have to go back and we have to find all the cutting things. It's not per sentence here. Short jackets require 1 hour cutting. So 1 hour for each Y. Long leather jackets require 2 hours from cutting. So 2X. And the total from the cutting department is 32 hours per week. So our cutting time has to be less than or equal to 32 hours. We want to make sure we keep cutting with cutting with cutting. Common units. So then we'll go back and we'll unpack the sewing in the same way. 3 hours from the sewing department for short, 3Y, plus 4 hours of sewing department from the long, so plus 4 for every X, and we have no more than 84 hours per week. And then that darn distributor cannot take any more than 12 long coats per week. So X has to be less than or equal to 12. So we need to find our feasible region on our graph. So these are both in standard form. Let me see, when X is 0, Y is 32. When Y is 0, divide by 2 there, X will be 16. So for that one, I'm going to graph from 16 to 32. Ruh-roh, 32 doesn't quite fit, does it? So I guess we'll go one space higher than the graph. And what are we counting by anyway? 3s? 3, 6, 9, 12, 15, yep. So 16 will be right here. Solid line, less than, so shade 0, 0, 0, 0 will be in the shaded region. Alrighty, standard form again. When X is 0, Y will be 84 divided by 3, 28. And when Y is 0, 84 divided by 4 is 21. So we'll need to go from X equals 21. So let's see, 18, 21 right here, to Y equals 28, which will be 1 higher than 27, right there. Shade underneath. And then lastly, the distributor can take no more than 12, so 3, 6, 9, 12. So less than or equal to 12, solid line, shade left. So that's going to cut this corner out right here. So we're lower there, we're lower there, we're lower here, all the way back to 0, 0. So this is our feasible region again, our possible answer region, and we wish to find out the vertices. So 0, 0, that's kind of a giveaway that that's not correct. 12, 0, we don't know. That one was 0, 28. And we aren't really sure. So what do you do if you have the we aren't really sures? Well, if you have the we aren't really sures, then we suddenly need to solve the system of equations. This system of equations was y plus 2x equals, pretend it's equals 32, 3y plus 4x equals 84, pretend it's equals. And we need to solve that by substitution or elimination to get the exact value of this point. We had all this estimating going on with the graph, so we aren't really sure where that is. So let's see. I think I'm going to multiply this by -3, and I'll eliminate my y's. Let's see, that's going to be 96, -96. So we would have -2x, 2x equals -12, so x will equal 6. And when x equals 6, I'll substitute that back into the top equation. Then y is going to equal 20. So 6, 20 is an intersection. That is right here. And then lastly, this guy right here. This one is going to be far easier for us to do because it's the intersection of x equals 12. Oh wait, we know x equals 12 already. And the diagonal line that had the intercept at 0, 16, 0. So y plus 2x equals 32, that one. So y plus 2 times 12 equals 32. So y plus 24 equals 32. So subtract 24 and get 8. So 12, 8 is our final vertex. When we're putting this profit equation down here, we may find it helpful to switch it around. Since our first coordinate is x and our second coordinate is y, let's go ahead and switch that around to be 80x plus 50y, and then we can make our substitutions. This one, obviously, if we make no long coats and no short coats, no long coats, our profit will be 0. Easy peasy. Okay, this one's just going to be 80 times 12, with the other one being 0. That's going to require contribute no profit. This one's just going to be 50 times 28 because the 0 contributes no profit. So 1,400. And then the ones we need to actually do all the math for. Most likely one of these will be the winner. I know which one I'm betting on. But let's let the numbers tell the story. So 1,480 or 1,360. Alright, since our goal was to maximize the profit, here's our winner, which tells us the answer. How many batches of short coats and long coats do you advise the designer to make? I would advise 6 for X. X was long coats. Remember to look back at your wording. And 20 was short coats. How much money will the designer make if he or she follows your advice? The 1,480 units are dollars. Alright, so give these problems a try and check your answers with the answer guide, and good luck to you.